Good afternoon, all of you. Welcome to another QA Tech Talk. Today's topic is microservices, anti-patterns, and pitfalls. Uh, Before starting the presentation, I'd like to show some cool thing about Google Slides. So while I'm presenting, you can visit to this site and you can ask any questions. If you have any questions, you can ask here. So I can see it in here, but so you can use that. But I'm introducing that. So start from the next presenter to use it. Okay, I'll start the presentation then. This is the today's outline. Since presentation about microservices have been done, I will briefly recap about what microservices are. Then I will briefly discuss about the monolithic architecture and the microservices architecture. Then I'll explain you about what an anti-pattern is and what an pitfall. And then I will discuss about the anti-patterns and pitfalls in microservices. So today's presentation I will discuss mainly about three anti-patterns. First one is the reporting anti-pattern. Then the second one is data-driven migration anti-pattern, and the last one is called the timeout anti-pattern. So let's move on with the presentation. So what is an microservice? So microservice is an architectural style which consists of loosely coupled services. So all of these loosely coupled services form the application. And the main important thing about this microservices architecture is that they should have the share nothing architecture. That means the messages passed between two or three microservices should be minimal. And the other thing is about the data management about those microservices is that each microservices have their own database, and they have this concept called bounded context concept. That means they are independent from each other microservices. That means one microservices has not the ability to talk to another database of another microservices directly. So it has this bounded context concept and the shared network architecture. So these are the two key features which we will discuss more about within this presentation. This diagram shows the difference between an monolithic application and a microservices architecture. So microservice architecture consists of various services. So the collection of all these services forms the application, and each microservice consists of their own database, and other microservices don't directly go to the database of another microservice. So they have to go through an interface or an service of that relevant microservice. And when you talk about the monolithic architecture, so it consists of one database and all the services which we have talked earlier in one layer. So that's about the brief idea about the monolithic architecture and the microservices architecture. So now I'll explain you about what an anti-pattern is and what an pitfall is. So anti-pattern is something which you feel it's good when you start, but when time goes on and when you experience things, you fall into trouble. So anti-pattern is something like that. So if I provide you an practical example, now in modern days there are various sugar-free products and sugar-free beverages. Most of the people get used to it to get refrain from getting diseases like diabetes and so on. And but those sometimes those sugar-free products are made. The sweetness of those sugar-free products get using an artificial components. So I have found that it can cause cancer. So I have received a question called test. I can see all the questions from here. And then what pitfall? When you talk about pitfall is something which is a bad idea from the start. So you should not follow that pattern from the beginning. So that's a difference between an anti-pattern and a pitfall. So this is the first anti-pattern which I am going to talk today. So I came across this when I was searching for methods to do reporting in microservices architecture. So the main issue in reporting in microservice architecture is that the data in microservices architecture, the data is distributed among various microservices. For example, if you need to create a merchant report, a seller's report, you might need the data of a merchant. So that merchant's data might be on another microservice on its database. Then to create that report, you might need customer and client's data. So client's data might be on another microservice. So you need to collect all those data to create a report. So there are a few techniques used in these used in microservices for reporting. So first three methods are not quite good because they have drawbacks and all those things. But the last method is the accepted one, and in our DGR project also we use this event-based pull model. So I'll explain all those things: the database pull model, the HTTP pull model, the batch pull model, and the event-based pull model one by one. So the first one is the database pull model. So in this, what happens is that the reporting service straight away pulls the data from the microservices. So if you think if you need to create a merchant monthly report, so on the day which they want to create the report, the reporting service queries the database directly and grabs the data and create the report. So it's the database pull model. So when you consider about the drawbacks and the advantages in this approach, so using this approach, it's the fastest and easiest way to get timely data. That means you can straight away access their database and grab data. So the timeliness is maintained. And when you talk about the drawbacks, the main drawback in this approach is that it breaks the bounded context concept. That means another microservice access data from another microservice's database directly. So it breaks the main concept in microservices. It's called a bounded context concept. And the other thing is that services don't own their data alone. That means now the reporting services grabs their data. So those microservices doesn't own their own data. Then the other thing is if there's any change or database schema refactoring on the microservices, those change should be done in the reporting service also, because you straight away query the database from the other microservices. So those are the advantages and drawbacks in using this kind of an approach. So the next approach is called HTTP pull model. So in this approach, what happens is that the reporting microservice creates an HTTP request for the relevant microservice and grabs data. So now if we discuss the advantages and drawbacks of the system. So this model supports the bounded context concept because we don't straight away call the database, but we create an HTTP request to the relevant microservice and grabs the data from the relevant microservice. And the main disadvantages in using this approach is that this is too slow, because you have to create an HTTP request and you have to wait till the data is fetched, and then you have to create a response from the relevant microservice and send it. And the other main drawback in this system is that think for a moment, now you want to create a merchant monthly report. Now if that merchant have thousands or 100,000 records per a month, then there will be a whole bulk of data. So an HTTP payload cannot hold that amount of data. So that request will fail in the middle or somewhere. So this model is also doesn't support the microservices architecture, and it's not a good pattern to use for reporting. Then the next approach is called batch pool model. So in batch pool model, what happens is that there's an batch data uploader. So when they want to create on a everyday evening or in a specific time, so what does this batch data uploader do is it queries the data from the databases and get the latest data, and if there's any modified data, they all grab together. And the main specific thing in this approach is that they use another specific database or a data warehouse for this reporting service. So what does this batch data uploader does is that every day at a specific time, evening or morning or any time of the day, it pulls data, newly added data and the modified data from relevant microservices. Then it modifies the data. So if you want to store data in a warehouse or some kind of that, you have to modify the data according to the reports which you are generating. Modify the data and you pull those data into the reporting services database. So that's that approach. So when you discuss about the advantages and disadvantages in this approach, is that the main advantage is that now you are using a separate database to store data from various microservices. So you don't need to grab the data when you create the report. So you can grab the data beforehand and store it in the reporting microservice. But the main drawbacks in this system is that this architecture also breaks down the bounded context concept, because the reporting microservice directly access the databases of other microservices. And the other thing is that in this approach is also if the database schema or any database refactoring happens on the microservices side, those changes should be reflected on the batch data uploader which you are going to use in the system. So that's about that approach. Then the next model is the event-based pool model. So event-based in event-based pool model, what happens is that each microservice creates an asynchronous event when a new data is entered into the database or the data inside them is modified, so that there's a data capture service. So all the events will be captured by this data capture service, and this data capture service will then store the data on the relevant database of the reporting service. So there's a question from some audience. So can you identify me if I'm logged in using a Google account? So it's anonymous. If you are using a incognito window, you are anonymous. Otherwise, if you are logged into the browser, your name will be displayed. Then that's about that thing. So in this approach, microservice sends data when there's a new insertion or a modification of the data. So when you talk about the advantages and disadvantages in this approach, so in this approach, the separate database or data warehouse is being used in the reporting microservice, and the other thing is that it preserves the bounded context. So now the microservice, other microservice data is not directly accessed to the databases, and the other thing is that this ensures timeliness of data, because although the events are asynchronous, but this guarantees the eventual consistency. So when you create a report, when you are creating report, that data will be there, because you don't suddenly create report. So because of that, you can ensure the eventual consistency. And the other thing, the other disadvantage in this approach is that it's a bit difficult to implement, because there should be an event emitter and then there should be an data capture service to capture all the events. And the other thing is that the data get duplicated because all the data on the other microservices should be duplicated on the reporting microservice. So in this approach, we mostly use a data warehouse because we modify the data, and to create faster reports, we modify the data and store it in the reporting microservice. So that's about the event push model. So when you compare all the four models, the DB bull model, it breaks the bounded context because it accesses databases of other microservices. And then when you talk about the timeliness of data, so it shows the highest percentage in timeliness of data because straight away you have the ability to access data from another microservice and create a report. And then in the HTTP pool model, it preserves the bounded context because you access the data through the microservice of that database, but it breaks the timeliness of data because because if the load is more, the HTTP request may fail, and it's very difficult to get complex data using an HTTP request. Then the third one is the batch pool model. So in batch pool model, it breaks down the bounded context because we straight away access the database of other microservices. When you talk about the timeliness of data, it does not guarantees because now the batch pool model runs on a specific time of a day. So from a moment it runs on an evening. But if you want to create a report including all the records on a day, but you can't create it because it runs on a specific time of a specific day. You don't have the records till the next day. You don't have the records of the night if you are on an evening. Because of that, the timeliness of data is not guaranteed in it. And the other thing, model is the event push model. So event push model guarantees the bounded context, so it does not straight away access database of others. And the other thing, when you consider about the timeliness of data, so it's little bit less compared to DB pool, but because it uses synchronous events, but it comparatively it ensures the timeliness of data. So comparing all four, the event push model is the best one to use in reporting in a microservices architecture. Then the next anti-pattern is the data-driven migration anti-pattern. So this anti-pattern mainly occurs when you are shifting from an monolithic architecture to an microservices architecture. So this the reason because this is an anti-pattern is mainly because at the start most of people think that it's a good idea to shift the service functionality as well as the data in a monolithic architecture to an microservices architecture. But when time goes on, you feel it will add additional migration costs, and it will cause high risks, and also it will cause excess costs if you straight away migrate the data and the service functionality to microservices architecture. So there are two primary goals in this conversion process from a monolithic to microservices architecture. The first one is to split the functionality of the monolithic application into small single-purpose services. So you have to identify what are going to be the microservices from the monolithic to microservice architect when you're moving from monolithic to microservice architecture. So it should be independent service. And the next goal is to migrate the monolithic data to services which you have identified. So these are the two main goals in the conversion process. So this diagram shows shifting from an monolithic to microservices architecture. So initially in this model they have identified 3 services. So with the 3 services they have created 3 databases for each microservice, and also they have migrated data into all these three microservices. But when the time goes on, these people identified that the leftmost microservice is more coarse-grained, so it need to be split up, and or the left these two are more fine-grained. They need to be consolidated. So in both of these approaches, so they have two databases on the first approach. They have one database. Now they are splitting up the microservice, so they need to split this database into two and migrate data into those two databases. On the second instance, now you are connecting these two microservices. Now there are two databases. Now you have to collect all the data and create one database and migrate all data into that database. So it's a cost because you have to do extra migration efforts, and you have to create databases here and there. So it's not a good approach in doing this. So what you should do in this kind of an approach is first move the service functionality. So service functionality can be divided. So you can identify that they have identified three microservices, but in this approach they have used the monolithic data as it is. So they have not shifted the they have not created unique databases for each microservice, but they have used the monolithic database. So understanding the risk involved with data migration and the importance of this data or functionality is the first step avoiding this anti-pattern. So now if you want to split the functionality, you can split it, but you don't want any migration because you are still connecting to the same monolithic database. Or now after some time when you feel that now the services are more granular and there won't be any splits or any consolidation, now you can start migrating data and creating separate databases. So with the time you can, with the gain of more knowledge, you can do that. So the best practice in this kind of approach is that you have to wait for some time, because at the start you don't know whether you have to split the microservice into two more microservices, so you want to consolidate two microservices into one. So you have to wait some time, and after some time, if there won't be any changes, if there won't be any granularity changes, then you can start migrate data and create separate database for each microservice. So that's about that anti-pattern. And the last anti-pattern which I'm gonna talk today is called the timeout anti-pattern. So microservices is a distributed architecture. That means that all of the components are deployed as separate applications. So there should be a mechanism to communicate between these microservices and connect these microservices. So in a distributed system, the two main concerns is the service availability and the service responsiveness. So the service availability is the ability of an service consumer, the one who consumes service, to connect with the service and to create a request. And the service responsiveness is the time taken by a service to respond to a given request after you have communicated with it. So the main goal in a distributed system is to cater for the service availability and the service responsiveness. Now think for a moment, so if there's an error, or if the communication breaks down, service consumer has the ability to pass that message to the client. But think for a moment, if the communication between the service component and the service consumer is completed, but there's no response from the service component, then what would be the approach for the service consumer to return a response? So in this approach, what we think is that giving a timeout for the service consumer would be the best choice. All of you think like that, but when the time goes on, this timeout value also not be a good idea. So I'll explain that how this is not going to be a good idea to have a timeout value. So when you are creating a timeout value, so these are the two techniques which have been used in creating a timeout value. So first approach is to calculate the database timeout within the service and use that as a base for determining what the service timeout should be. So you can calculate the database timeout within the service and you can use that as a base to create an timeout service. Then the next approach is to calculate the maximum time under load and double it. So you can measure the maximum time which the service takes to get a request and create a response for some request, and do it under a maximum load and double it. So this is an example how you can do this. So this service consumer places an trade order on a service component. So the average time to create and trade request to the service component and to get a response out of it is 2 seconds, but the maximum time under a load, the maximum time to take is 5 milliseconds. That means 5 seconds. So under a load, it will take 5 seconds to get a request and provide the response to the service consumer. So the timeout value for this kind of scenario would be 10 seconds. So timeout value would be 10 seconds. But now the drawback in this approach is that now for every request, service consumer waits for 10 seconds. So if there is not any response from a service component, service consumer have to wait 10 seconds without doing any task. But in nowadays, most of the users expect a result after pressing a button. I don't think anyone would wait for 10 seconds or kind of thing. They would wait more oftenly 2 to 3 seconds. So in this approach, if there's no response from the service component, service consumer will wait for 10 seconds. So this is one drawback in this kind of system. So the main solution for this approach is called the circuit breaker pattern. So circuit breaker, so this is the usual circuit breaker which we are using in our houses. So when the circuit breaker closes, it conducts electricity, but when the circuit breaker opens, it does not conduct electricity. So in this approach also what happens is that if the microservice is unresponsive, the circuit breaker would open so that no request would be passed over to the relevant microservice and no request will be passed over. So soon when there's a request from service consumer, circuit breaker knows that whether the microservice works or not. If it does not work, it straight away send that an error message or something which they want to send. But when circuit breaker is closed, when a request is sent, it will pass over to the microservice and get the request. So in this kind of approach, the service consumer does not want to wait for a response from a microservice. It knows whether the microservice works or not straight away. So there are three methods which you can use to implement circuit breaker to check whether the microservice works. So the first one is to do a simple heartbeat check. That means you can ping to the microservice and check whether that microservice works. Then the next approach is to use a uh, use a synthetic transaction. So what do you mean by an synthetic transaction is that to send a fake transaction periodical service. So you send a transaction, fake transaction, and check whether the microservice works. And the other last thing which you can do is that real-time user monitoring. So you can monitor the microservice works on real time, but it's bit costly. So without much cost, what you can do is to do an simple heartbeat and check. So those are the main anti-patterns which have been used in microservices. So that's about it. Any questions?